Welcome everyone to today's webinar, Discover OCI Vision for Object Detection in Manufacturing, Retail, and more. My name is Nikki. I'm a Marketing Event Manager for the Developer Initiative here at Oracle. And today we're excited to explore how OCI Vision can identify, classify, and quantify visual data in powerful ways. We have also set up a Slack channel, Cloud Coaching North America, in our developer workspace that you can access at the QR code or the link on the screen. And before I pass it off to presenters, I wanted to let you know we have more amazing AI-focused webinars just like this one coming up. You can check them out using the QR code. Today's webinar is presented by Chiang-Mai Tucker. Without further ado, I'll pass it to Chiang-Mai.
All right, so welcome everyone to today's webinar. Today, we are going to go ahead and look at OCI Vision for object detection. My name is Chinmay Thakur. I'm a senior cloud engineer at Oracle. I work in the Code Innovate team. So the agenda for today looks something like this. We are going to go ahead and look at the OCI Vision overview of what exactly the OCI Vision service is and how it is used. Then we'll go ahead and look at 4 different topics or domains within the OCI Vision service. That is object detection, image classification, face detection, and text detection. After that, we'll take a quick look at the use cases and then jump into a demonstration of how you can go ahead and use the OCI Vision service. I'll then pass it on for a quick overview of our Code Innovate program to Sean, and then we'll have Q&A at the very end. All right, so going into what OCI Vision Service is all about, the OCI Vision Service is an AI service for performing deep learning-based image analysis at scale. So you can go ahead and use our OCI Vision Service, which is industry-specific use cases can be used by developers, and you do not need to kind of know any machine learning expertise for using our Vision Service. All of these are pre-trained models that you can go ahead and directly use to analyze images. You can also customize some of our models using our custom models within the AI service. The OCI Vision service is a fully managed service, so you don't need to care about the underlying infrastructure of where the service is running or what kind of model it's running. All of that is taken care of you. And lastly, it completely integrates with our OCI data labeling service. So within the image for data labeling or labeling within the different objects within the image itself is something that is integrated within the OCI Vision service as well. This is a quick diagram to show how the OCI Vision service works. So as you can see on the left-hand side, you can go ahead and ingest the data or your images from either our OCI object storage, or you can go ahead and use your local storage, your local PC or computer or directory where your images lie. All those images are then ingested into the OCI Vision service, which contains our pre-trained models or your custom models. The OCI Vision service will go ahead and do computation on those data or images that you have and store that result in a JSON format in our OCI object storage buckets. Now, these outputs can then directly be used by multiple different services within OCI. So as you can see, you can use it for Apex applications and search modules in the autonomous data warehouse for analytics and multiple different services. So it is as simple as just taking an image from your local desktop, putting it into the OCI Vision service, seeing the outputs, and using it for different applications. We look at what the OCI Vision service provides, and these are nothing but our pre-trained models and our custom models. So the first thing we're going to look at is the different varieties that we have in the pre-trained models. The first is object detection. Object detection is nothing but it detects the location of various objects that are there within an image. It will also give you a bounding box around all of the objects that are identified within that image. The next thing is image classification. Um, In this part, it will go ahead and look at the image and classify the image into a specific label. So let's say, for example, if there is an image of a car, it will specify that that specific image is for a car. There's also something called as face detection, wherein if you give an image which contains multiple faces, it can go ahead and detect the faces, the location of the faces in that specific image, their features, as well as the visual quality of that image. And lastly, we can also go ahead and recognize and digitize text, which are part of a specific image. So these are all the pre-trained models that we had. So for example, for using any of these models, you do not need to go ahead and train a model like you have to do in normal machine learning. So you do not need any of the previous processes to train a model. These are all trained for you, and the images that you go ahead and feed into these models will automatically give you an output based on the previous training that these models have had. But for example, if you want to have your custom model and you want to go ahead and train the model yourself so that for your specific use case, the OCI Vision service acts correctly, we go ahead and also provide two different custom models in object detection as well as custom image classification. All right, so diving deep next into object detection. So object detection is used to locate and identify multiple objects which are there within the image. And what the object detection model does is, as you can see on the image on the left-hand side, if there is a car, it will go ahead and figure out multiple things within that specific image. So it'll find out the door handles, the windows, the wheels, the logo of the car, something like that. So all of those different objects that are there within the image will be captured by the object detection module. What are the results that the object detection module will give at the end is something called as a label. Label is nothing but the object name that has been detected out of that specific image. So it may be a chair, a sofa, or a TV, or in this case, it's a car. It'll also give you a confidence score, and confidence score is nothing but a simple uh, number between 0 and 1, which shows how much confidence the model has in actually detecting that specific object. If the score is closer to 1, it indicates that it has a high confidence in justifying that that object is actually the one that is labeled along with it. If it's lower, then it has a lower score for that detection. It will also give you a bounding polygon. So it will give you an entire square around specific objects that you go ahead and detect within this image. There'll be coordinates, X and Y coordinates for each of these bounding boxes for each of the different objects that it detects within a specific image. So these three things are something that we get as outputs in part of JSON output when we go ahead and use object detection on a specific image. All right, going forward to image classification. So this is nothing but it classifies an image or multiple things within an image based on your use case that you have as to what that image is all about. Again, it is similar to the object detection module, but this will classify the image into a certain type of image or multiple objects within an image into a certain type of image. Again, the other things that are outputs of image classification that we get are labels again, which is nothing but what that specific image is. You always get a confidence score assigned to it, similar to what we had for object detection. And lastly, we also get ontology classes, which is nothing but categories in an image that show the properties and the relations between them. So let's say, for example, in this specific image that we have, there's a train going along and there's tracks as well. So there is a correlation between, let's say, the train and tracks. It will go ahead and show some kind of relationships in terms of ontology classes for that specific image. The next thing we want to go ahead and look at is face detection. So let's go ahead and look at a simple example where you have an image for different faces that are part of that image. what the face detection module will do is it will go ahead and find out the existence of faces within that specific image. It will go ahead and bound the face of that the faces that it finds with a bounding polygon. It will also find out major landmarks within each of the face. So it'll find out the left eye, the right eye, the tip of the nose, as well as the smile or the end of the lips of that specific person that we have found in that image. It will also assign a score of how good that image is in terms of visual quality. And face detection can be used for multiple different cases in terms of privacy. Let's say if you detect a face and you want to blur those face out so that no one can know what it's about, we can go ahead and use that for privacy. It can also be used in photography to see how visually clear a particular image taken is. And it can also be used for digital asset management. And the last thing we want to go ahead and look at in terms of the pre-trained models that we have is text detection. OCI Vision Service can go ahead and detect and recognize the kind of text that is part of an image that you go ahead and provide as an input. It can go ahead and extract specific words from within that image, or it can also go ahead and extract lines altogether from that image. It will also go ahead and provide a confidence score, which is again a score from 0 to 1, saying how much confidence it has in detecting that specific text. And it'll also bound that specific text with bounding polygons, just to detect where that specific text has been found on that image. So looking at common industry scenarios and use cases of where OCI Vision Service can be used, these are some of the use cases that we can use. The first one is in retail. So let's say, for example, in a store, you can go ahead and check how many people are coming within the store, how many products are there within that store. A product catalog classification can be done if there are any defects in specific products, in terms of when you go ahead and return products, or you can go ahead and detect all of those using OCI Vision. You can also go ahead and pick up some social media posts or do sentiment analysis on images that have been sent as feedback from customers. There's also text detection that can be done on shipping label information, which can go ahead and extract all the information that's there as part of a photograph of your shipping label. The next is in manufacturing. So you can go ahead and do counting of the number of products that you have by just taking an image of the entire product inventory. We can also go ahead and figure out whether certain people are actually wearing their hard hat and have the right protection and the goggles while using in those manufacturing environments. We can also go ahead and detect any defect in equipments or products. We can classify multiple products according to their SKUs. And we can also go ahead and use text extraction from shipping labels, similar to what we did for retail. In terms of media, we can go ahead and use OCI Vision, like I said, in digital asset management. We can also go ahead and do some brand protection. So let's say, for example, if you want to go ahead and protect some specific brands or blur out some logos, that's something that we can always go ahead and use in by using OCI Vision. We can also go ahead and detect specific logos, or sponsor ROI analysis can also be done. In healthcare and in public safety, we can go ahead and use OCI Vision in PPE detection. We can also analyze medical images. So let's say, for example, doctors can directly go ahead and scan specific images or patient x-rays that they can go ahead and pick up certain kinds of anomalies from specific images. Within hospitals, we can also go ahead and observe patients as to how they are doing within their specific rooms. And also this can be used for public safety in terms of license plate detection and crime scene detection. It can go ahead and create a simple report or documentation using our other Gen AI models as well. And the last thing we can go ahead and look at is the energy and water utilities. So you can go ahead and look at how the vegetation is in a specific area. You can also check how the poles are they decaying, are they rotting, if they need any uh, updation or any repair work that can be figured out really early by taking an image and continuously monitoring them using our OCI Vision service. We can also check what is the water level, if it's actually going low or high by taking multiple images and feeding them to the OCI Vision service. So these are nothing but simpler use cases that can be used in our industries by leveraging the capabilities of our OCI Vision service. I'll go ahead and jump directly into the demo now. So, all right, so this is our OCI Vision service. I've logged into the tenancy that I have, and the landing page over here kind of shows you everything about the OCI Vision service. There are some video tours as well as some self-paced workshops that you can go ahead and follow to learn more about the OCI Vision service. But to simply go ahead and see what Vision can do and what are the different features that we saw in the PowerPoint is right here on the left. So we'll first look at image classification. We have some demo images already uploaded within over here so that you can go ahead and see what the image classification module does. As you can see on the right hand side for the specific image over here, you can see overhead power lines, which has been correctly classified by the models, the pre-trained models of the image classification, and it gives you a confidence score assigned to it. Initially, I did say that the confidence score is a number from 0 to 1, but over here, it has been converted into a percentage format for easy readability. But if you go on the response, it is actually a JSON response that you get back when you go ahead and upload an image within the image classification. Like I said, it go ahead and label the specific image as to what it thinks to be the right classification. As you can see over here, the confidence score for the specific image is 0.993, where the label is an overhead power line. It also detects a road over here, so it also has a high confidence score for the road, and various multiple things that it goes ahead and detects. The other thing that we spoke about was the ontology classes is nothing but relationships between multiple different things that is detected within this image. So let's say over here, it went ahead and detected something called as vegetation, and also kind has ontology classes and parent names, which can be something but plants. So plants, vegetation is something that it automatically detects and provides to you as part of the image classification models. You can also go ahead and look at a different image over here, which has been provided nothing but a simple denim jeans. It correctly classifies this image as a denim with a high confidence score. It also finds a pocket with a high confidence score and multiple different things within the image. The response will be similar to what we saw for the previous image, with the label of the specific image along with its confidence score and the multiple different ontology classes that it recognizes. Also, when I said in the initial diagram as to how you go ahead and use image classification, you can go ahead and directly upload a local file over here or drag and drop your JPEG or PNG images over here, or you can go ahead and select an image which is already present within the object storage. So if that's something that you want to go ahead and do, that's well and good as well. Or if you want to use the local option, that's perfect as well. The next thing we'll go ahead and look at was object detection. So if you go over here on object detection side, again, similar ways of where your image can lie from your local file or from the object storage. These are some of the pre-added images or demo images that you can go ahead and look at, and how object detection kind of detects multiple things within this specific image. So as you can see, in object detection, it will identify multiple objects that it finds within that specific image. So over here, it identifies multiple different cars within that image, as well as a bus over here. It also binds the entire object that it finds with a specific polygon. So as you can see, these square boxes or rectangular boxes that you see are nothing but polygons, which are the location within the image where it finds this specific object. Again, if you see, it does go ahead and come with a confidence score. So if I go back to our response, it will go ahead and give you the label, the name itself. So it is a car, the confidence score, which is a 0 to 1 value with a high confidence value if it actually detects the car correctly, as well as the bounding polygon. It's nothing but X and Y vertices. It actually starts from the top left and goes to the top right, and then bottom right, and then bottom left. It'll give you all those coordinates with respect to the size of the image. So if this image is has certain pixels in width and certain pixels in height, you can go ahead and multiply the X coordinate of the specific vertices with the width of the image, and multiply the y coordinate of this with the height of the image, and you should be able to get a specific point of the polygon that has been created within that image. So these are nothing but the 4 different endpoints of this polygon for a specific image. So again, it detects multiple different objects within this image. It detects a car, and the next thing, it detects the bus at the back as well. Looking at a different image over here, it will go ahead and detect a person. It detects the helmet that the person is wearing, a human face, and it goes ahead and labels all of them along with the confidence value that it has and the bounding polygon with the 4 vertices of that polygon. All right, then. So that concludes a little bit on object detection. We'll directly jump into face detection. Similar to the other two, we can go ahead and input them using the local file system or the object storage uh, file location. And within this image, as you can see, it detects the different faces that are there within a specific image. It will give a confidence score assigned to that specific face as well. And if you see over here, it also quickly identifies different dots. So it finds out different features within a specific face, like the left eye, the right eye, the tip of the nose, and the edge of your mouth. So on the left edge and the right edge of your smile. And this can kind of be used in multiple different ways. So the outer bounding polygon will always remain the same, but then if the uh, edge of your smile is a little bit closer, then it says it might be frowning. Whether if it's wider, then it can show that the person's actually smiling, and that's something that can be detected based on the distance between all of these specific points that are found within the facial recognition. So if I quickly look at the JSON response that we get for the specific image, it will go ahead and give you the detected faces. It will give you the confidence score of those specific faces, as well as the bounding polygons, which is nothing but the square or rectangular faces boxes on the specific image. It'll also give you a quality score, and this is nothing but how clear the quality of that specific image is, or of that specific face is. It'll give you a quality score assigned to it as well, which can be used in multiple different photography use cases, whether a specific picture taken is actually clear and the face is actually visible by looking at just the quality score. And like I said, there are multiple landmarks that it finds within each of the faces. So as you can see over here, it says left eye is on this specific coordinates within that image. There's a right eye, the tip of the nose, the left edge of the mouth, and the right of the edge of the mouth, which can be used again to to find out whether the person is actually smiling or it's his normal expression. If I'm going to go ahead and look at a different image over here, again, it identifies the face, bounds it with the bounding polygon, and finds out the multiple different locations within that specific face. So this is a quick overview of the face detection part. And now let's go ahead and look at text detection. And this was the image that was part of the presentation as well. A simple image about a road sign which says what direction you're going in, it's an interstate highway, what route you're taking. If you click an image and put it up there, the text detection will go ahead and find out all the different texts within that specific image. You can go ahead and extract all of these by line, or you can do it by individual word. So over here, as you can see, belt route is just on a single line. So it is, when you do extraction by line, it'll show it like this. Or if you do it by word, it will take each and every word into consideration and split them up that way. If I look at the JSON response, it might be similar to what we have seen for all the others. It will go ahead and identify the text itself. It'll give a confidence score assigned to it as to how confident it is in actually identifying what that specific text is. It will also give you the bounding polygon, which is nothing but the place of where the text is within that specific image. So over here, as you can see over here, the text interstate is right over here. It gives a confidence score along with the bounding polygon for that specific word within that image. Similarly, if I look at another image, it will go ahead and specify what it is. So over here, it's a school bus. It finds out all the different texts that it finds within this image, along with the bounding polygons with it. And this can actually be used in multiple different ways in terms of, let's say, tax, in terms of highways where you want to go ahead and pick up some toll, you can go ahead and quickly take an image of the car passing through that toll booth, which kind of picks up the license plate and everything, other details of that car. And you can go ahead and extract this information and directly go ahead and write an application to bill those person while crossing to a toll plaza. So text detection is something that can be used in that sense as well. The last thing over here is also something called as video analysis. And this is not something that we saw in the PowerPoint, but I just want to show as part of the demonstration. You can go ahead and upload a video, and it can go ahead and do these possible different things from within that specific video. It's nothing but label detection, object detection, text detection, as well as face detection. So if you want to go ahead and apply all of these models within a specific video that you go ahead and upload in OCI Vision, these specific models will be applied to that video and it will give you a result over here. So let's go ahead and use the demo video. As you can see over here, I've already specified an output location of where the output JSON will go ahead and reside for this specific video. I've used my specific bucket with a prefix of just AI. So if I go ahead and quickly go ahead and analyze the demo video, as you can see, there's a job running, and that's the video that was running over here. And as you can see, the video is pretty short. It just shows a birthday cake. There's Max Verstappen over there, the F1 driver, and then there's some text at the very end. Now, if I go down to the results, we applied 4 different kinds of pre-trained models over here, which was label detection, object detection, text, and face. Over here, it will show you each of the labels that it detected. All the labels can be found over here, but if you want to go ahead and parse the video, you can just click on this and it'll show you at what specific period of the video, what labels are detected. So as you can see here is darkness. Here is a human face, a cloth, cheek, forehead, a hat that the Max is wearing, and everything else. Similarly, for object detection, you can see that it was able to identify the candle, the cake in this specific video. On the next part, it also went ahead and identified a human face. It specified the hat that the person is wearing, etc. And lastly, in terms of text detection, we had text coming in at the very end of this video. As you can see, this is the text at 4 seconds in the video, and here's where it actually goes ahead and detects all those texts from within the video as well. So here's too many more is everything, all the text that was detected as part of this video. And if you want to go ahead and look at where it was, you can directly click over here and it'll navigate to that specific part of the video in which the text was detected. And lastly, there's a face detection. So one face was shown throughout this video. It will go ahead and give you the same results of the face detection with a bounding polygon for that specific face within where and the time in which this specific face was visible during the video. So this was simply how you can go ahead and use OCI Vision service in multiple different ways, which was image classification, object detection, face detection, text detection, and video analysis. One thing I'm want to show you but not going to cover as part of this demo is you can also go ahead and create a custom models. You can go ahead and create a specific project for yourself, and within the project you can create a model which can either do image classification or object detection. In this case, you will have to go ahead and supply your set data set or images that you want to go ahead and classify, and then you will have an option to go ahead and manually classify all of those images or detect objects within those images yourself as part of an initial training data set. Then you can go ahead and train that model based on that, which will then be available for you to apply to any follow-up images that you want to classify using the custom model that you have built rather than the pre-trained models that we have. So that's something that's also possible. But the two limitations is that we can only use currently image classification and object detection for these. All right, so going a little deeper into how you can go ahead and use this in, let's say, code. So I've gone ahead and used some Python code as well, where I have written the code to classify images as well as object detection. I'm going to use this specific image over here. I've uploaded this image in our object storage as well. So if I go to bucket, I have a demo bucket in which I've uploaded this same specific image. I'm going to go ahead and reference this specific image when I go ahead and call my code. As you can see over here, it's an image classification code, and I reference that specific image which is in the object storage to go ahead and classify this image for me. So if I go ahead and quickly run this code, scripts, and then image classification. So what this will do is this code actually goes ahead and utilizes the OCI Python SDK for our OCI Vision service. I'm using that to going ahead and classifying the specific image that I showed you earlier. And as you can see, I've gone ahead and printed out the most probable object that this specific image classification model can classify. And it classified it as a dog with a confidence level of 99.37%. These are the top three, and this is sorted by the highest level of confidence that it finds from within this image. But at the bottom, I've printed all the different classifications that this specific model did for the image that I provided. And as you can see, the classification, these are also sorted according to the confidence score. And as it goes down, the confidence score goes down as well. So it also went ahead and found out some denim, asphalt, parking with a lower confidence score, but the highest confidence score was for a dog, which it correctly classified for this image. Similarly, I'm going to go ahead and run another script for object detection for this specific image. Again, this image is again stored locally as well for me, as well as I've stored this image in the object storage. So I can use both ways to go ahead and uh, detect specific objects from within this image. So if I go back and run the next script for object detection.
Hey, Chinmay, sorry to interrupt, but just for the audience benefit, you could do the same sort of analysis using the interface in the OCI console. You just chose to use the Python STK to run the scripts, correct?
Correct. I just wanted to show
Okay.
how you all can go ahead and utilize this within your existing applications. If you all have one, you can directly use the OCI Python SDKs within your existing application scripts or Python applications to utilize the AI capabilities and detect images and objects from within whatever sources that you have.
Thank you.
All right. So when I go ahead and do the object detection part, um, it will go ahead and also bring up an image over here with the bounding polygons for each of the different things and stores that as an output image over here. So as you can see, it does go ahead and figure out all the different kinds of objects that it finds within this image, the dog, the car, the van at the very back, the trees as well. It bounds all of them with the bounding polygon, and it also provides that as an output over here. So as you can see, similar to what the output, the JSON output that we saw in our OCI console, we can get a similar output in our Python code as well, similar to the bounding polygon with the vertices, as well as the confidence score and the label for that specific object. So this was a simple demonstration of how you can go ahead and use the OCI Vision service, both in our OCI console directly or using Python SDKs. You can go ahead and integrate each of these services within your projects to go ahead and enhance your specific applications with object detection AIs. I'm going to go ahead and pass it on to Sean to give you a quick overview of our Code Innovate service. So Sean, you can go ahead and take it away.
So my name is Sean Cartwright. I'm a senior cloud engineer as well and a program manager here at Oracle. So I wanted to tell you a little bit about a program that Chinmay, Cypria, and I have been a part of for going on over 4 years now here. We work for a team known as Code Innovate. And what is Code Innovate? Well, to explain our program, I liken it to an activity that our director would do most every year with his kids when they were a little bit younger. So he would take his kids on a trip to the Legoland amusement park. This one just happens to be near Chicago. So out of all the attractions and activities at Legoland, their favorite thing to do was to participate in something called the Lego Master Builder class. So during this class, all the kids were given their own clear plastic sandwich bag of disassembled Lego pieces without any instructions, much like you typically find in Lego sets that you buy in the stores. So the adults in the front of the room, pictured in the top right-hand corner of the picture with the green polo shirts on, they were known as Lego Master Builders. So over the course of the event, they work with these kids on the concept of brick interlocking and how to create smooth faces on objects by arranging them different ways, using the Lego pieces. So on this particular day, they built these little penguins with earmuffs that you see on the bottom. So the goal of the class was first and foremost, they wanted the kids to have fun and enjoy themselves. However, in a very short amount of time, they learned to build with Legos in a creative environment using techniques that they were taught by true experts that worked for the company. And we tell that story because we believe in its simplest form. Like that's what we do here at the Oracle Code Innovate program. So what it is a 5 half-day online event designed to educate professionals like yourselves on Oracle Cloud while producing a first pass prototype on your selected business use cases that you guys bring to us. So over the course of a week, participants from your teams are paired up with an Oracle engineer to guide you through best practices and co-development on working on an actual use case prototype. So during this time, you're going to brainstorm on the business challenge. You're going to identify different tasks to complete to reach the end goal, and you're going to partner with us to create a minimally viable product. So whether you're a novice or a pro in Oracle Cloud, you've been working with a few services, or if you've been using a lot of different services, we're going to meet you where you're at and help you get to where you want to go. So Code Innovate in its essence is all about helping you build solutions for problems that you guys find really important that you bring to us. So to explain how the process works, we ask you to bring your use cases, like I said, because we want to work on things that you guys find important and that you want to work on. Secondly, what you get out of the program is that very rapidly you're going to get upskill because whether you've been using the product or if this is the first time that you're going to be using any certain product, you're going to be getting hands-on help and guidance via what we call cloud coaching. But essentially, we're going to be over your shoulder, helping guide you through the user interface, telling you where to click, and helping you through the process of development from start to finish on the prototype. So it's a very hands-on effort. And secondly, like I said, we're going to build a first pass prototype together. So a point that I would like to make is that our program does not only assist with Oracle AI services, although that's what the demonstration was built on today on object detection, but we support builds with many different infrastructure and platform services on Oracle Cloud. Things like, Chinmay and Cypria happen to be, subject matter experts in different cloud native stuff. So things like Oracle Kubernetes Engine, Docker, and creating CI/CD pipelines. We do things like that. We support Oracle Analytics Cloud, OCI data science and AI services such as this, Oracle Digital Assistant, like our chatbot platform. That's something we commonly see in use cases. Oracle Integration Cloud, which is our application integration platform, because most everything needs to be integrated, different data sources, source targets. Visual Builder Studio, which happens to be a CI/CD pipeline tool for Visual Builder Cloud Service. So all of that to say that most times our use case builds involve multiple services that comprise the entire prototype itself. It might not just be one service, it might be multiple. But I make this point because oftentimes our webinars are just based on a single product or a topic, but our team is capable of resourcing specialists from within our immediate team and a larger organization to meet your needs. So everything that our team works on is a custom built prototype tailor fit to the use case. And lastly, to illustrate the point I was making, here's a larger list of some of the different types of use cases and some of the different types of products we work with. This is not an exhaustive list by any means, but we encourage you to reach out if any of these pique your interest. So you see here, analytics, Oracle AI services, chatbot, cloud native, containerization, object storage, the whole gamut, including Oracle Apex as well. So with all that said, I just appreciate your time today. Here, there's a QR code on the screen that leads you to our public YouTube playlist, where essentially what we do is some similar demonstrations like what Chinmay did today. Those are a part of the playlist, and different use cases that have been anonymized that we've done in the past 5 years are going to be on there as well. So, if you're interested in engaging, send us an email. The email is down there on the bottom of the slide. It's the codeinnovate _US_GRP@oracle.com. Or if you happen to know your Oracle Cloud platform representative or an architect or someone associated with your customer, you can reach out to them. If you don't know who that person might be, you can send us an email, and we can try to route you to that right person and get a lead established in the system with Nikki and the marketing team. So with that being said, like I said, I appreciate your time, and it was nice talking with all of you.
If you like today's session, we'd love to invite you back to check out our other upcoming events. We'd also like to hear your feedback and what topic you'd like us to cover in the future. With that, I'll go ahead and end today's session. Have a good day and hope to see you soon.